welcome to Manufacturing 2. We're talking today about some introduction to G&M codes. And this is just an introduction. We're going to cover a lot of codes that you need to understand how they work so that you can learn to operate a CNC machine. These aren't specific to a mill or a lathe. They're just general codes that apply to most CNC machines. So let's get rolling. So essential question here is, how are some of the common G&M codes used to control CNC programs? That's what this course is all about. My objectives behind this and the handout that accompanies is for you to demonstrate understanding of some CNC program structure. What does a program look like? A few basic G&M codes. We're going to discuss the idea of word addresses and modal codes, and then talk about some of the G code groups and how that limits their use when you're running a machine. So first, let's start out with program structure. Now, if you were to look at a G-code program, the things that will pop out to you is, first of all, we kind of have to learn, what are the names and some of the meanings in it. We're going to learn about what a safety codes are, or safety blocks that kind of reset the machine between operations so we don't have something bad happen. And then we're going to talk a little bit basically about some of the profiles, tool selections, canned cycles, that idea of modality in the machine operation, and then how we stop the program and reset the program. Now, if you were to look at the program itself, you would see something that looks like this. And this is a really, really simplified version. So this is a text import program, and it's HAWS specific. There are a few things we'll point out as we go through here. But we're going to look at this basic program and figure out what some of this stuff means. So the very first thing we're going to start with in red here are these percent symbols. Those percent symbols come from the text file import into the controller. So that helps the machine know where the code starts and stops. It's used for text-based programs. The next line down, this is really the name of the program, and that's an O code, and that's a reserved word, O. So when I say a reserved word, it means a word that starts with a letter like O. So O is the word. It's a reserved word. It's only used once in the program, and it cannot be repeated in a memory. And what that means is this is the name of the program. If I put another program into the machine that's named O00344, the machine is going to ask me if I want to overwrite the prior version. So that's really the name of the program, the O code. Next to it are the parentheses, and those are remarks. Those are for humans. This is to explain to the next operator or to you, because sometimes your programs are pretty long and substantial, what exactly you're doing here. So on that O code, our class standard is always put your name in there and then a description of what the project is. Everything within the parentheses forms a remark. The computer ignores the remarks. Now, you do have some limits here. You can't put more than one remark on a line. And generally what we're doing is we're describing names, describing tools, actions, and giving meaningful information to the next person who runs the program. The computer just skips over it. End numbers, those are those things in front of the lines, and those you can think of actually as line numbers. Now, some CAM packages will put end numbers in for you. You can manually put them in also. You just have to be a little careful with these if you're not automating their input. And there's a couple reasons for this. If you run a macro or a small subroutine, it may loop out of the main program and then look for an end number to return back to. Now, if you use your end numbers poorly and you alter them, but you reference it later on in a macro, you're going to have a bad result out of that. So you got to be kind of careful how you use your end numbers and how you change them, because they can have implications. We'll learn more about that later on. Other interesting thing is the computer doesn't really read them except for macros. So you can use line numbers N10, N10, N10 all the way through. Not super clever, but you could. So end numbers are for humans also, except for when the macros are running to try and find the location in the program. Well, here's the number one error you're going to make when you're writing programs, and also the number one error you're going to see when you're trying to run your own programs. So in red, you have a semicolon. That's called an end of block marker, and effectively what that does is marks the end of the word sentence, and that block of words is what the computer will execute through the servo and the encoders, and that's what it will look to run. It tells the computer this is a line of code. That is not in any way related to a line. I can have a piece of program that extends past one line, the number of characters that are available in the display, but that end of block marker instead marks the end of that processing step. So that's an end of block marker. Easy to forget. Also easy to put in the wrong thing. Put a colon in instead of a semicolon or a comma. Those will all create errors. So your turn. What symbol marks the start and end of the code? Yeah, it's that percent symbol, isn't it? What do we call that semicolon at the end? It's the end of block. And then are the n numbers, shouldn't be end, are the n numbers required? Unique or easily kept track of manually? The answer to those is all no. So that's your n numbers, not end. How many remarks can you have on a line? Yeah, it's one. So awesome. So let's move on. Now, after we cover the basic structure, we're going to talk about the idea of a safety block, and these are useful defaults. And I'll tell you what these are. These are essentially defaults to make the machine reset to a condition just like you just powered it up. And the reason we do that is if the person in front of you had an active macro or something running, and you accidentally started that program up in the middle of that macro, it may not behave the way you want it to behave. So these safety blocks are useful defaults. Most modern machines have some things where they reset at the end of the program, but I'm going to teach you to put these in all the time. We've got a set of blocks made up for lathe and for mill. They're sitting up here. Right in front of your screen, G18, G20, G40, G54, G80, G97, G99, and then a G17, G20, G40, G49, G80, G98 for the mill. That just sets what XY plane it's going to arc in, puts the machine into inches, turns off any cutter compensation, turns off tool lengths, canned cycles, and then it returns to the start point if it's in a canned cycle. So pretty basic stuff, but we're going to do that every time when we write a program. A lot of times I'll advise you to put that safe start line in at a tool change so that you can safely start your program from a tool change location and not have anything weird happen. Now, similarly, just like we had to have some stuff to start the program, like a name and that percent mark, when we shut the program down, we want to do it methodically. And some things that we generally want to do is we want to position the work so we can get it out. So on a mill, we'll bring that table in front of us so when we open the doors, we're not reaching in real far. It's optional, but it's a good idea. We want to turn off coolant, we want to stop our spindle, and we want to clear the tools away from the work also. So that's the idea of things that you'll see at the end of a program. Not all required. Some are done by default, like turning off the coolant will actually be done by default when you stop the program. But there's a difference between rewinding the program and stopping the program. So there's three common ways to stop the program, and M1 is an optional stop, and that just means the program will pause whenever the op stop button is depressed, every time it sees M01. And M02 just says stop the program now, and it stops the program. It ends it. You can't really start the program up from that. And M30 stops the program and then rewinds to the beginning of the program. And that comes from the days when CNC machines ran off of tape and the tape would physically rewind. So M30 is very commonly the last code in any CNC program. Number one use for that. So here's a code sample. Again, I've just added some more information in here. I've got my safe start line in there, and I've also put in here, where my cursor is flashing, some remarks. And this is where I'd put how do we set up the stock, and then any other setup instructions, like maybe the tools that are used in here. You'll see that my program ends down here, and I don't have an M30. So it would not go back to the beginning. So your turn. What's that safety block do? Yeah, that safety block basically resets the machine to a power-up condition and cancels any macros or any program, any weird parts that are in my program, so I don't inadvertently do something. What is the program name in this? It's that 00344. Right, awesome. So let's talk about some basic stuff here. So the program or the machine is controlled by a series of codes. We call that programming method G-code. Now it's made up of what we call a series of words. And the G-code words are just the letters. So an example, G01 is a linear movement. That is a word, G01. It's a form of motion. So the different letters mean different words. So G words set preliminary conditions. So like a G01, it tells it to move. It doesn't tell it where. So that G01 needs to be accompanied with directions. Where is it going? How fast is it going? M words are sometimes called M codes, turn specific things on and off. They're like a light switch. D, H, and T words define tools and offsets, diameters, heights, and tool numbers. F and S words define feed, how fast the tool will move, and S, how fast the spindle will spin. There's a lot more address words, I, J, K, N, X, Y, Z, K, P, Q, A, B, C, U, V, W, E. More on those later. Don't worry about them. Just remember G, M, DHT, F, and S. So G words, preparatory. They tell a machine to do something, but it's got to have more information. Generally, these always need a destination, a speed, and rates. So as an example here, in this first line, where my cursor's flashing, G00 is a rapid move. I need to tell it where to go. It's going from its present position to the coordinates X1, Y1, to whatever work offset is set. The next one is a linear movement, G01. It's going to that X1, Y1, Z1 at a feed rate of 20 inches per minute. And the third one down here, this is G54. This just says, hey, use this offset that's in the memory location for G54. So G codes are grouped, and you can kind of imagine why. The like commands are grouped. As an example, group 1 are all motion commands: rapid, linear, arc clockwise, arc counterclockwise. And they're grouped like that because I can only do one at a time. I can't tell it to rapid and then move in a linear pace. The two are incompatible, so I can only do one at a time, and that's why they're grouped in that fashion. So when you look at these G-code groups, I've got group 1, they control motion. And I can only have one run per block. So I can either make it go rapid, or I can make it go linear, or I can make it go clockwise circular, or counterclockwise circular. So group 1 codes, only one can be active per semicolon. Same thing with group 6. The machine can either run in inches or in metric. Same thing for group 7, for the compensation and the cutter length and cutter compensation. So only one group at a time. Otherwise, you're going to get an error. I believe it's a 339, and that's a multiple command error. The red light will come on. You go, oh, I think I broke something. You didn't. You just told it to do two things at once it couldn't do. And the example that I give kids is if I told you to walk, run, forward, backwards to QT, you'd look at me and go, I got no idea what you mean, buddy. So that's what you're telling the machine. So in this instance, I'm telling it to go G54, linear movement, G01, at this feed rate, turn the coolant off at the end. Now if I come down here and I say two commands, G54, G01, and then I tell it to move X1, Y1, Z1, feed rate 20, and also rapid to X1, it goes, I got no idea what you want. Now another multiple command is if I give it two switching operations, two M codes in a single block, it's going to throw an error. So I can't tell it to do M09, turn off coolant, and M03, turn on the spindle. Those are incompatible. Only one M code per line, which we'll talk about here in a second. So multiple codes, that's error 339. You've got multiple G codes from the same group, you've got two or more M codes in the same block, and you've got two or more feed rates, tool selections. I don't know what else here. PTQ, IJK codes in the same block. Those are probably less common. You're less likely to do that. I will tell you the number one reason this happens is two M codes or two conflicting G codes. You made a mistake. Now, a short word about decimals and zeros, you got to understand. So zeros mean something in the CNC world. Leading zeros are not needed, but for codes, I'll tell you, if you always get in the habit of typing M6 as M06, it'll be a little easier to read your code. I find it easier to read your code. Now you need decimals because these mean something. If you leave a decimal off of a number, the machine assumes the smallest units it's capable of measuring. And I'll say that again. The machine then assumes the smallest units it's capable of measuring. So as an example, the position X20 with no decimal really means 20 thousandths of an inch. 20 ten-thousandths of an inch. So this assumes a 10,000th. So that should be 20 ten-thousandths of an inch. So you may give it a feed rate of F20 with no decimal, and then you'll say, Mister, the machine's not moving. And I go, oh, it's moving. It's just moving incredibly slow. It's moving 20 ten-thousandths of an inch per minute. So you can't physically see it moving. So if I want to write the position 20 inches, it's X20 decimal. That's different. Now the trailing zeros here, it carries these way out. That's 20 inches. Same thing for time. If I put in G04, P20, which means pause 20 seconds, or when I don't put the decimal in, it means pause for 20 milliseconds versus 20 point, which means pause 20 seconds. And that G04 is not right, but the P word is pause. So more on M codes later on, but remember that M codes essentially take effect like a light switch. They turn on and off. They stay on or off. They're persistent in the last state they were in, and you can only have one per semicolon. So here's some common ones. M8 and M9 turn the coolant on and off. M3, 4, and 5 turn the spindle on clockwise, on counterclockwise, and M5 spindle off. So that kind of makes sense. So M codes are modal. That means that they stay in effect until I turn it off. So in this example, on line 12, M08, I turn the coolant on. The coolant stays on in line 13, 14, 20 until line N99, and then I turn the coolant off. So that's what's turning my coolant off. So that means it stays in effect. Also, M03, turn the spindle on. That spindle is spinning all the way through these codes, all the way up till I hit this M05, which stops my spindle. So M codes stay on like a light switch. Modal codes are codes that stay in effect until they're turned off or superseded by another code from the group. So a lot of G codes are modal. So example, motion control, G00. If I tell the machine to move rapid, I don't need to tell it to stay rapid every time I tell it to move. So look down here to this line N13. If I tell it move rapid, to X1, Z1, and then I tell it to go X0, Y0, Z0, it does that moving rapid because I never told it to do anything else. And I'd equate that again to me giving you a command that said run. And I'd say run forward. And then I say turn right. Well, you're still running. Turn right. You're still running until I tell you stop. Or I tell you walk. So that's modal. It stays in effect until you turn it off. Some of the modal commands that you're going to see here, the most common ones you'll see, are the motion commands. D, H, and T, those choose toolings. So T is a tool number. Our tools are numbered in the mill. They're numbered from 1 to 20 for the stations that hold them. In the lathe, they're numbered from 1 to 12 for the stations that hold the tools. I can turn cutter compensation on and tool length compensation on for the tool. So D is use the diameter of the edge of the tool to compensate its path. H is use the end of the tool length to compensate for its tip. You'll learn much more about that later on. But these DHT codes go with tools. FIS codes, I already kind of relayed those. That's a feed and a speed. So remember I said a lot of G codes, they need more information. One of the pieces they need is a feed and a speed. This is modal. So feed rates and speed rates stay the same unless they're overwritten. So you need to set your feed rate. So if you come in here and say G01, feed rate of 20 inches per minute, go to X1, Y1. It's modal. It'll keep running that. So I can tell it to go to X2, Y2, it'll still go at 20 inches per minute. Now if I tell it to go G00, which is rapid, it ignores the feed rate. Now the next feed rate that I tell it to do, it goes back to the prior feed rate. Spindle speeds are the same way. Now this you kind of got to be careful of, especially if you're using an edge finder. If you were just running a program and you had the spindle spun up to 6,000 RPM and you put an edge finder in, start a new program, and you want to turn the spindle on, so you close the door and you hit the forward button, that spindle spins up to 6,000 RPM and your edge finder flies apart inside the machine. So beware of the spindle being modal. Always set a speed on that when you're manually using it to do things like touch off or find edges. Address codes are just that. The address codes tell the machine where it's going. Some examples of address codes that you're going to see here are XYZ, that's a position access. We're going to go in X, Y, and Z, the 3 dimensions we've learned about. IJK are incremental positions that go along with that. And then ABC are rotation, UVW are incremental position. We'll learn much more about that, but this grid is pretty handy. X, Y, Z, it goes U, V, W, I, J, K, A, B, C. So if you can remember that grid, that's handy for later on. So this was just a brief introduction into some G code. At this point, you should be able to take your notes for this and fill these out. If you have a hard time, go ahead and go back and watch the portion of the video that talks about this. When you're done with this, you're going to turn that in. The next thing I want you to do is to watch AHA's tip of the day about these basic introductory G codes. And remember, this is just an orientation to allow you enough information so when you're operating the machine, you understand what it's about to do. Thanks for watching.